Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. As I scan the words of this word problem, I keep wondering at what point can I pause to digest and make some kind of inference? And I think for this question, that would probably happen right at this comma. Because at that point, that's really the first time throughout the problem that I can kind of pause and say, okay, what does this mean? I have the price per apple, I have the price per orange, and now I'm told that Mary selected a total of 10 fruit. I can make an inference now about how much money Mary would have to spend. Now, I can't say exactly how much it would be, but I can come up with a logical range. And I'm curious, maybe I'll just ask you all, can you type in the chat, what's the logical range for the total amount of money that Mary would have to spend on 10 pieces of fruit? Perfect. Exactly. Yeah, she's going to have to spend somewhere in between $4 and $6. And this kind of thinking is really good for the GMAT. This kind of, I call it range thinking, right? Thinking about the minimum and the maximum, and then concluding that it has to be somewhere in between those extremes. Now, under what circumstances would the total amount spent be closer to $4 than it is to $6? Yeah, if she's purchasing more apples than oranges, then she's going to spend an amount that's closer to $4 than it is to $6, and vice versa, right? If she's buying more oranges than apples, then she's spending closer to $6 than to $4. So then I keep on reading, and I pause at the period, and I ask myself, does this even make sense? That the average amount that she paid per fruit was 56 cents. And my answer is, yes, it does make sense, because you'd expect it to be somewhere in between 40 cents and 60 cents, and indeed 56 cents is inside of that range. But I can take it a bit further than that, can't I? The fact that 56 is closer to 60 than it is to 40 implies that Mary bought more oranges than apples. So now I can say it was at least 6 oranges and at most 4 apples. That's what she bought. But we can't stop there. It would be a mistake. It would be a huge mistake to keep reading the question now. We're almost definitely going to fail if we keep reading now. What we should do instead is dig in a little bit deeper and say, look, here's the apple side. That's the 40-cent fruit. Here's the orange side. That's the 60-cent fruit. And where does 56 fall within that range? So we already saw that it was closer to 60 than it is to 40, but how much closer? Like, what are these distances? We've got a distance of 16 here and a distance of 4 here. And the ratio of those distances is 16 to 4, or if you reduce, 4 to 1. And I'm always going to put the winner on the left when I write out the ratio. So I would have 4 to 1 to 5. I always start with a bigger number on the left, so that way I don't make any careless errors, right? I know that the winner is going to be on the left of my ratio, and I can visually see that the oranges are winning. So oranges to apples to total are at a ratio of 4 ratio units to 1 ratio unit to 5 ratio units. But I still shouldn't stop, because I know the total number of fruit is 10. So I can put that 10 under the total, and now I can also infer that the scale factor for my ratio is 2, which means that the actual number of oranges was 8 and the actual number of apples was 2. And I really think that if we don't go the whole way to this final inference that I have on my slide now, and instead we keep reading, we finish reading the question, we're not going to be able to succeed in this question. So now we're ready to keep reading the question. We're probably about 1:20 in at this point, I would guess, something like that. And we read, how many oranges must Mary put back? Oh, so she hasn't actually purchased them yet. She just selected these 10 fruit, and she's actually going to put back some of them, which I think during a pandemic is probably not the right thing to do. Like, once you've touched it, you got to buy it, right? But this was written before COVID. How many oranges must Mary put back so that the average price of the pieces of fruit that she keeps is 52 cents? So now we no longer know the number of oranges, because she's going to be putting back some unknown number of oranges. We also no longer know the total number of fruit that she'll have, because that's going to be 10 minus whatever the answer is. 10 minus however many oranges she puts back. The only thing we do know, the only thing that's going to stay the same, is the number of apples. That's not changing, and that's really the key to unlocking this question. So the number of apples is definitely going to be 2. I don't know the number of oranges, I don't know the total, but I do know the average is going to be 52 cents. So I'm going to draw a new number line, and this time I'm going to place 52 somewhere in between, approximately where it should be. So we've got 12 to the left and 8 to the right. So a ratio of 12 to 8, that's a ratio of 3 to 2. I can still see that the oranges side is winning. This is kind of like a tug of war, right? The oranges are pulling harder than the apples. So the oranges are still winning, so that's the ratio, 3 to 2, for a total of, again, we have 5 ratio units total. And this time, the only thing we know for sure is that the actual number of apples is 2. And now I can see that the scale factor of my ratio is 1, and I can fill in the rest, although really the only thing that I care about is the actual number of oranges. So we had an actual number of 8 oranges, but now in the end we have an actual number of 3 oranges, which means that Mary put back 5 oranges. And you can see how one of the trap answers there is 3. And that's just a horrible thing that can happen on the test, is you do all of the work perfectly, and then you accidentally answer the wrong question. They're not asking how many oranges will she still have at the end, they're asking how many must she put back. And that's why it's so important to pay attention to detail and to really look at what they're asking for. Hey, I'm just going to interrupt my own video for a moment here. If you're finding value in this video, please let me know in the comments below. And give this video a thumbs up. It really motivates me to keep uploading a new video every day. Alright, back to the video. Okay, so with functions, a lot of people I think really struggle because they have a hard time understanding what a function really is, or what it does, or how to think about it. What I suggest is that we think of a function as like this kind of mysterious black box that receives an input, does whatever it is that that black box does, and then it spits out an output. And that mystery that happens inside that black box, that's the function. So a function could, for example, double whatever input it receives, right? You throw in a 5, it spits out a 10. You throw in a -2, it spits out a -4. So that would be a function that doubles the input. A different function maybe cuts the input in half. You throw in a 20, it spits out a 10. You throw in a 0, it spits out a 0. It's just going to spit out half of whatever input it received. Another function maybe adds 7. So you throw in a 3, it spits out a 10. You throw in a -4, it spits out a 3. It just adds 7 to whatever input it receives. So that's just conceptually, that's what a function does. Now, in this question, there are 5 answer choices, each of which presents a certain function. So the function in answer choice A receives some kind of input, and then it squares it and spits out the output. So it just squares whatever input it received. The answer choice B, what does that function do? It adds 1. It adds 1 to whatever the input was, then spits out the output. And so on, right? So this function in answer choice C takes the input and square roots it. It takes the square root of the input and spits out the output. And the fourth answer choice takes the number 2 and divides it by the input. And then whatever remains, whatever is there, that's the output. So it takes 2 divided by whatever the input was. And finally, the last answer choice just multiplies the input by -3 and then spits out the result. But the question itself is asking specifically about the kind of function that essentially wouldn't care whether you throw in a sum of 2 things or whether you throw those 2 things in individually and then add up the outputs. So I guess you could ask yourself, I'm just going to take as an example, okay, 7 is the sum of 3 and 4. Isn't that true? 7 equals 3 plus 4. So as I look at these answer choices, would the output be the same whether I threw in 7, again, just as an example, versus if I threw in a 3 and separately I threw in a 4 and then I added those two together? Like, would these be equal? Would the function not care how it receives the input? As 2 separate chunks or as a sum of those chunks? That's really what this question is asking. So whichever answer choice you're working on, that's the black box. It's the same black box. And the question is, does that black box give you different outputs when you give it a sum versus when you split that sum into chunks and throw in 1 chunk at a time? So let's see if we can come up with an actual real-life type of function that would work that way. Brushing teeth. If I throw into the teeth brushing function all of my teeth in one go, then the teeth brushing function would have all my teeth brushed. That would be the output. All my teeth are brushed. Versus if I throw into the teeth brushing function just my upper teeth and let it do its thing, right? And then when it's done, I throw in my lower teeth and let it do its thing and it's done. In the end of the day, the outcome is the same outcome. All my teeth are brushed. So that's the kind of function that would work well for this question, right? It doesn't care whether it receives the inputs in piecemeal or all together at the same time. What's a kind of function in real life that wouldn't work for this question? If the function is painting cars, like at a auto manufacturing plant, you're painting the cars. If you throw in 2 cars at the same time, then the paint machine can't work all the way around each car because the cars are presumably touching each other, and so then you're not going to be able to paint them properly. Whereas if you throw them in one at a time, then they'll each come out perfectly painted. So that's what this question is really about. It's asking, is this the kind of function that would care whether it's receiving the 2 pieces together as a sum or independently one after the other? And Jessica already told us that answer choice A would not work for this, right? And that's true because we know that if you were to square the sum, that is not going to be the same as squaring each of them separately and adding together. Because if you square the sum, you'd have an extra term called 2ab. So where is it? Gone. So A doesn't work. What about the second answer choice? If I throw A plus B in together as a sum and then add 1, that's what the function does, would that be the same as just putting in A and then putting in B? Is that the same? No. So B isn't right either. Now conceptually, if A doesn't work, C won't work either, because A and C are the same type of operation. They're just the opposite direction. But hopefully you also know that root of a plus b is not the same as root a plus root b. And if you don't know that, you can just plug in a couple of numbers and quickly check. Like 9 and 16, for example. Root of 9 plus 16 is not the same as root 9 plus root 16. I purposely chose two numbers that are perfect squares, such that also their sum is a perfect square. Right, so the left side is 5, and the right side is 7. They're not the same. So C is gone. We're down to two answer choices. I'm curious, can you all type which of those you would pick? Which of the last two? Which one do you think would spit out the same output regardless of whether it receives the sum or individual parts? Yeah, so you're all getting that right. 2 over a plus b is not the same thing as 2 over a plus 2 over b. You'd have to do a common denominator, right? So it would be 2b plus 2a over ab, if I'm not mistaken. That is not at all the same as 2 over a plus b. I wonder, does anyone here think that in the future, if you get a question like this, you'd be able to pick out the right answer at a glance without pen and paper? I see at least one person nodding. This is the distributive property that we learned in grade 3, I think. Right? That a times b plus c is ab plus ac. It's the distributive property of multiplication. That's really what they're testing here. And that's how I think it is possible to solve it at a glance. You just look at the answer choices and you're looking for something that works with the distributive property, and multiplication, of course, does that. They made it a little bit harder by putting a negative sign in there, but of course that negative sign doesn't make a difference conceptually. So that would be the fast way to solve this question, is to understand what it is that they're trying to test, and then pick out the answer choice that would work with the distributive property. The b plus c in the distributive property example is the a plus b here. Imagine the following question. I'm just going to make up a question that could be a GMAT question. You're a store owner, so you sell stuff at your store, and today you sold 2 items. On the first item, your profit margin was 15%, and in your second item, your profit margin was also 15%. And you didn't sell any other items today. Okay, so you only sold 2 items today, and on each of them, it just so happens your profit margin was 15%. Can you tell what your overall profit margin for the day was? So 15% is correct. And I just want to show you kind of mathematically why that is. This is really related to the question that we just looked at. Conceptually, it's testing the same thing. Let's call the price of item number 1 A and the price of item number 2 B. My profit margin was 15% from each. That's my profit margin from A. Oh, that's my profit, not profit margin. This is profit from A, this is profit from B. Altogether, you see what I do here? I pull out the 0.15 as a common factor, and I get this. You see that? So that would be the mathematical proof for why the overall profit margin for the day is also 15%. Now, if they had different profit margins, I would not be able to answer the question. I would be able to say it's somewhere in between. It's a weighted average, and it would be closer to whichever item was more expensive, because that one would carry more weight in terms of the overall profit for the day. But because they both had the same profit margin, we can do this kind of thing. And this is a distributive property. So the reason why we can answer the question that I made up is thanks to the distributive property. When you're multiplying 2 different items by the same factor, you get the same result as if you had added those 2 items in the first place and then multiplied by that factor. And that's really what that question was testing, in my opinion. I think if you can at least intuitively lean into answer choice E, right, and then maybe you still need to prove it to yourself, and that's okay, but at least if you can start with that one, because it seems like the distributive property would work there, and then you can test it in the following way. You could say, okay, for answer choice E, we have -3 times A plus B versus negative 3 times A plus negative 3 times B. And you ask yourself, are these two sides equal? And you'll pretty soon see that, yes, they are. And then you can pick E. So if at least intuitively you can lean into answer choice E and start with that one, then you can save yourself a lot of time. Okay, so that was 2 minutes. I think this is also a very hard question. I think all three questions so far today are quite difficult. But I guess that's why we're here. So we have a group of 20 people drinking coffee, and then they start talking about cream and sugar. And so I'm thinking, if you're a coffee drinker, you could take both cream and sugar. You could take neither cream nor sugar, or you could take one but not the other. So this is a classic overlapping sets question for which we should use the double set matrix, also known as Carroll's diagram. I'm going to start setting that up. So we have cream, not cream, total. We have sugar, not sugar, and total. And we know that altogether there are 20 people, so I'm going to put that right in there. The total number taking cream in their coffee, so that's this cell right there, bottom left, is 7 less than twice the total number taking sugar. That's this cell here in the top right. And I think it's time to start introducing some variables. You know, I'm not a fan of algebra on this test, but I think it can't be avoided here. So if I were to say that the number here is x, then twice that would be 2x. And we know that this is 7 below that, so 2x minus 7. That's what goes in there in the bottom left. And I like to go very slow when I'm translating something like that onto my paper because it's very easy to make a mistake. If this is particularly hard for you, what you can do to double check that you did it correctly is just throw in some random number for x real quick. Like say, okay, what if x is 10? Well, if x is 10, then twice that, or 7 less than twice that, 7 less than twice 10 is 13. And then you can plug in x equals 10 and see if you get 13 for the bottom left. So that would be a way to double check that you did it correctly. I'm continuing to read the question now. The number taking both cream and sugar, so that's this upper left cell, is the same as the number taking neither. That's this middle cell. Now I made one big mistake so far, and I wonder if any of you noticed the mistake that I made.
You haven't filled out the chart yet, so you can fill out the no cream and you can fill out the no sugar.
Bravo, Jessica, you got it. That was my mistake. I didn't pause long enough at the period to make all of the inferences that I could possibly make. You see, if we know that the upper right is x and we know that the bottom right is 20, we can infer that this is 20 minus x. And we absolutely should do that before we read on. Similarly, I know now that the middle bottom is 20 minus 2x minus 7, and so I'm doing a little bit of a calculation here on the side because I don't want to make a careless error. So that's 20 minus 2x plus 7, so that's 27 minus 2x, like that. Now I'm ready to read on, and I'm just going to decide to call these y. These are both y. Now the question is asking how many people in the group take cream, and we called that 2x minus 7, so I'm just going to write here 2x minus 7, put a circle around it, because what I don't want to happen is that I end up solving for x, and then that's going to be in the answer choices as a trap answer, and then I'll pick it happily and move on to the next question, forgetting that they're actually not asking for x, they're asking for 2x minus 7. So before I solve for x, I like to make a big note for myself on my scratch paper. What is it that I'm actually trying to solve for? Okay, now how are we going to find 2x minus 7? What do we have to work with here? Well, I can say for this upper middle cell that that's x minus y, just by looking at that upper row. That middle cell must be x minus y. And now looking at the middle column, I can build the following equation. X minus y plus y equals 27 minus 2x. So the minus y and plus y disappear. And if I add 2x to both sides, I get 3x is 27, so x is 9. And of course 9 is in the answer choices, as I knew it would be, because I know all their tricks. I know how they're going to try to get us. We're not solving for x, we're solving for 2x minus 7. So 2 times 9 minus 7 is 18 minus 7, which is 11. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.